All right, here we go, folks. So you'll notice that we skipped over example 2. I'm picking ones that I think resemble the homework as closely as I possibly can. So example number 3, this would be an example of a drug trial, all right, to see if a particular medication is effective in combating a disease, in this case breast cancer. So we have a medication called anastrozole, I believe it's pronounced, and like most drug trials, they give the medication. Well, let's start over. They give a placebo to one group of people. And again, population 1, population 2, it can be either way. But let's suppose since the information about the placebo is given first, we'll call that population number 1, all right? A sugar pill, not the medication. And then group number 2 would be the group that was actually given the medication. All right, so we have the control group, the placebo group, and then the group that actually got the medication. Now, it doesn't matter. We could put these the other way, and perhaps maybe I should have. But here's the idea. If this medication is effective in combating breast cancer, let's talk about this. So P1 would be the percentage of women who took the placebo and actually ended up getting breast cancer, unfortunately. And then P2 would be the percentage of women who took the medication and unfortunately ended up with breast cancer. So I know this can be a little tricky, but if you think about it, if that drug actually was effective, wouldn't the percentage of women who took the placebo and ended up with breast cancer be higher than the percentage of women who actually took the medication? That would prove that the drug was effective. Now, had I defined these the other way, then it would have been less than. So it doesn't matter which one you call 1 and which one you call 2, as long as you use proper logic after you set up the 1 and 2 as to what that would be. But the women who took the placebo would have a higher incidence of breast cancer than the women who actually took the medication, as I have defined these. So, much like example number 1, and again I recommend you watch these in order, then we pull the algebraic manipulation of subtracting over the P2, and so that relationship right there would translate into P1 minus P2 is greater than 0. Just subtract over the P2 and this becomes this. Percentage 1 minus percentage 2 is greater than 0. And these are interchangeable, that's why I put a double arrow there. And again, I would suggest to you that that alternative hypothesis therefore would say that the medication is effective in combating breast cancer. All right, so I'd like to label that so that by the end of this question, 10 minutes later, we'll remember what the hypotheses represented. All right, similarly to the one before, then the null hypothesis would be that the difference in those two percentages is in fact 0. So I want to again remind you, if you would look at the general steps for performing a hypothesis test, the alternative has your inequality and the null would have your equal. All right, what's that saying? Let's assume there's no difference between the two percentages. Let's assume that the medication and the placebo have no difference in terms of their effect in combating breast cancer. That's the idea behind that, all right? And today I wore my breast cancer shoes, all right? So, anyway, here's our test statistic. We've already mentioned that. We'll point out that it's got Z here. So, that would be our standard normal distribution bell curve, 0 in the middle. All right, and alpha, which is mentioned in the question, we are familiar with the idea that alpha would be the level of significance, 0.5% here. This person wants to be very stringent. 0.5%, which is 0.005. Remember, you would move that over 2 places. So be careful, if there's a decimal there, I see that as 0.5%. So move the decimal over 2 places, that'd be 0.005. And once again, because of the greater than statement that we see in the alternative, we would put that in, and the upper tail And so again, the stats nerds would call this an upper tail test. Now remember, this is important that this says Z back here, so we're back to, we're not gonna look anything up in the T table on these. But that Z table, recall, the one that I keep harping on you is the one that I find to be the easiest historically for my students to understand. Always wants that middle sliver. So if you take 50% minus the 0.005, that would be 0.4950. All right. So why am I doubting myself? I don't know. I just don't want to mess up one number here. So indeed, that's 0.4950. I don't know why. Never mind. Okay. So middle sliver 4950, and look, I don't have a lot of space on the board to redo things we've talked about before. I hope, I know you can't see it on the video, but look up the table. You'll find that that's between 4949 and 4951, and in fact it's a tie. So that would be the average of 2.57 and 2.58. And we've talked about that quite a bit. So that would be 2.575. We've looked up Z-scores based on different middle sliver percentages several times in the past. So you gotta be a snob and go, remember that? We did it. Okay. So we're gonna reject that null hypothesis if Z turns out to be greater than 2.575. Greater. Upper tail, greater, greater. It all goes back to this. All right, now the computation. So this is where the data would come into play. This is where you actually go give the medication to two groups of people. Well, you give the medication to one group, and you give the placebo to another. Keep in mind, one is placebo group. They call that the control group, I'm pretty sure, right? So P hat 1 would be the fact that out of 85, out of 100, let's start over. Out of 1,944 women who were given the placebo, 85, unfortunately, later developed breast cancer. Now, I believe 85 divided by 1944 is a nasty decimal, so we're just going to do it for accuracy's sake. We'll need to leave that in fraction form when we set this up. So 85 over 1944. P hat 2 would be the women who took the medication, and let's see, 40 out of 1,920. This is based on a news story that I saw several years ago, so I have to acknowledge to you that I don't know if things have changed since that story first came out as to the effectiveness of this medication. All right? So I honestly cannot tell you how old this example is, but I did get it from a news story. P bar, by the way, that's a nasty decimal. P bar would be to pool the two groups together. That's basically add the two numerators, add the two denominators. So 85 plus 40 over 1944 plus 1920. The total number of women who developed breast cancer divided by the total number of women who participated in the study. All right? And so again, that would be just some straight up addition. That's 125 over, I don't know, I want to be careful here. 1944 plus 1920 would be 3,864. So there were 3,864 total women who participated in the study, and unfortunately 125 of them developed breast cancer. That's the interpretation of that. And then Q bar would be 1 minus that. And in the interest of space, we'd want to change the 1 into 3864 over 3864. And so basically, out of the 3,864 total women who participated in the study, this would be the number of them who did not develop breast cancer. 3,739. Again, P and Q have to add up to 1. And I'll keep in mind, I changed the 1 into 3864 over 3864 in order to get a common denominator, arithmetic, blah, blah, blah. All right, so, whoo! This is nerve-wracking because I'm not sure. I'm going to write these off to the side where you can't see them so I can plug them back in later. P bar equals 125 over 3864. And Q bar is 3739 over 3864. You can't see this, but I have to look back at them to remember them. So I believe what I'll do now is I'm going to erase this area, right? I wrote them down over there, okay? You have them. Here we go. So now we're going to go plug these numbers into this beautiful formula here. And so we would have Z equals, marker going dead on me. Man, there's all kinds of things happening here. Keep shaking these markers, keep them going here. All right, now, again, unfortunately, these are nasty decimals. So P hat 1 was 85 out of 1944 minus 40 over 1920. And that would be the P hat 1 minus P hat 2. Leave them in fraction form. You can type it in the calculator like that and let the calculator crunch it all out. Minus, all right, as mentioned on example number 1, we're assuming there's no difference between the two groups, that the incidence of breast cancer, the probability of getting breast cancer, is 0. The difference, there's no difference, all right? And that's the assumption that scientists make. They assume that the medication does not have any impact, and then we hope that assumption can be rejected by a scientific study to show that it is actually effective. That's the whole idea. Okay, and then the P bar, Q bar, all right, that'd be those two fractions I wrote off to the side. This is nasty. Look, in some cases, if you want to decimalize both of these, you can probably get away with it, but I would caution you, if you do decimalize these fractions, keep as many digits as you can on those decimals. I'm going to leave them in fraction form. Oh man, that's messy button pushing here. And then N1 would be sample size number 1. That would be the 1944 plus, all right, P bar, Q bar, same two nasty fractions here, 125 over 3864 over 3739 over 3864, and then sample size number 2, N2 back here, was the 1,920 women. Whew, that's a lot of button pushing, and I don't know what else to tell you. Multiply these, divide by this, write it down if you need to, save, store it, keep as many digits as you can. Keep as many digits as you can. You round too early in the middle of a math question and things can really get out of hand. I feel like my hands are tied here. I don't want to be a total snob, but I have to be. That's the order of operations. Crunching numbers with a calculator was a skill that you brought with you. And so, fingers crossed. I don't know what else to do here. Wave your hands in the air, da-da-da. Turns out that Z ends up equaling 4.021. Yes, a lot happened between here and here. I'll just tell you, I've used this example for quite a while now, and I've been pleasantly surprised how many people, when I put that number on the board, they're like, yeah, that's what I got. And so, I don't know. I wish I was here to be able to read your faces and be able to tell if that made sense. I don't know. What can we do here? But notice that is out there beyond the statistical threshold. That is in that upper tail. That is in that rejection region. It is above the 2575. We're going to reject the null hypothesis. Awesome. Okay, so we're going to reject that null hypothesis in favor of the alternative. And notice that the alternative said that the placebo group had a higher incidence of breast cancer than the women who actually took the medication, which in turn means the medication is effective in combating breast cancer. So, awesome. Okay, now I have to acknowledge to you, there's my breast cancer shoes. It's even got the breast cancer ribbon on them and everything. I ran the New York City Marathon in these shoes. I bet they smell really good, don't you think? But anyway, I honestly don't know the update on that medication, and I'm very curious to go look it up now and see if there have been additional studies. I will tell you these numbers were based on some actual numbers that I saw on a news report. I don't know if this video is going to play. I've had some trouble with these, so this might blow up in my face. I'm done doing the question. I hope it made sense to you. I'm going to play the story that I hope, well, I don't know. Is it here? I'm looking for it. Let's see if it plays.
We're back here with, as we mentioned, some good news about fighting breast cancer for women at high risk. There may be a new way to prevent the disease without all the side effects that so many people have come to dread. Ann Thompson has more tonight on the new research presented today at a meeting of breast cancer specialists in Texas.
That something new is actually an old drug. Anastrozole, sold commercially as Arimidex, has been used for years to treat postmenopausal women after they've had breast cancer fueled by estrogen. Now a study published today says anastrozole can help prevent estrogen-fueled breast cancer in high-risk women,
in the first placebo-controlled trials,
decreasing the risk by 53%. Researchers say it's a home run. The study involved almost 3,900 postmenopausal women between the ages of 40 and 70 who were at increased risk for breast cancer. Half got anastrozole every day, others got a placebo. After a median of 5 years, 40 women on anastrozole got breast cancer versus 85 in the placebo group.
So I just wanted to convince you the numbers in this question were actually based on an actual study that was performed. And again, that was several years ago, so I don't know. But it sounds promising. I hope that that medication still holds up, and we might go read more about it. So anyway, we will enjoy one more example. It'll be the Vietnam draft lottery question that we looked at way back before spring break. See you in a few.